Good morning, Johnny, Wasner, Matthew, Stephanie and I are from BNH Consultants, and we're here to talk you through our progress in design so far. Firstly, just a reminder of our brief. We were tasked with designing and developing a terminal facility fit for cruise vessels at a Northern Irish port that will fulfil the needs of the industry until the year 2030. We were given a series of deliverables, including a berthing solution scalable to the needs of the cruising industry now and both in the future, an aesthetically pleasing development that was also scalable and fit for purpose, an infrastructure solution to serve the facility, and it had to be a development that would bring revenue to Northern Ireland. Firstly, we had to select a site upon which to build our facility. 5 towns and cities were considered, including Derry, Portrush, Larne, Belfast and Bangor. These were initially assessed on a criteria matrix, using criteria such as the size of land available in the area, any finance that was available, and existing transport and infrastructure. The highest score was awarded to Belfast, and so we proceeded with our developments in this area. Following that selection, there were a further 5 sites considered within Belfast, being North Foreshore, which was a previous dumping ground, Stormont Wharf, an existing container facility, Alexandra Port, just at the back of Titanic Quarter and near the city centre, Hollywood site, just west of the Hollywood residential area, and the Don Wynn Power site, which is southwest of the Hollywood site and adjacent to the RSPB bird sanctuary you can see between the red and the blue sites. Again, a matrix was used to assess these. This time the criteria was more site specific. This time we used the area of land that was available, the navigable depth and the channels around it, and the aesthetics of the area itself. The 2 highest scores were awarded to the Hollywood and Dome site, and on the 15th of October there was a site visit to both sites to get a bit of a feel for the area themselves. We decided after the site visit we'd proceed with the Hollywood site because it became apparent that a potential 5-year lease on a Dome site for any future wind farm developments was likely to come up in the next year.
Currently the Hollywood site is an unused open space in the Belfast port area. The site has approximately 400 metre revetment in the direction of the Victoria Channel in the shipping lane in Belfast, and a 450 metre revetment in the direction of the lock. Currently each of these revetments are not capable of berthing a vessel due to the shallow waters. There is also a jetty in the northwest corner of the site. From this jetty we were able to see the water depth is actually 6.5 metres below chart data, meaning that this small area of the site is capable of berthing smaller vessels, which is also in the direction of the shipping. From primary borehole investigations, we found that both within land and marine boreholes that the land was made up of made ground. This has been well known in the Belfast area in the port. There is also much alluvium soils in the form of Belfast leach, which in the area of the land boreholes overlies peat and silty sands, followed by a glacial tilt and a very weathered weak sandstone. Eventually bedrock was found at around 30 metres. The existing revetment is not suitable to berth a ship as mentioned before. However, from the jetty we can see that the water depth is 6.5 metres below chart data, making this area suitable possibly berth a ship. We have decided from our proposal that the quay wall should be extended approximately 20 metres out towards the jetty direction in 400 metre length, as this area will be suitable for creating a berth. We've also decided to include modular design in our presentation. This is the idea that although cruising industry may not be as great as it is in the future, there is also the possibility for extension in years to come. We considered 4 different options when deciding upon our quay wall. First being concrete contrafort unit. This presents an efficient concrete gravity wall, more efficient than the block wall. However, the complexity of the wall, including its joints between the units, added difficulty and a cause for concern. This option requires a foundation trench, and some excavation of the current rock revetment would be required. The temporary works needed are very costly, as well as the difficulty in transportation of these large units due to their size. A mass concrete block wall was also considered, and this requires significant volumes of concrete, making it very materially intensive. Part of the rock embankment would also be required to be removed. However, in the past, this option has been successful, as the life cycle advantages it has due to its robust design and construction method. We considered a reinforced concrete deck and open pile structure as an alternative to the material gravity-intensive option. Use of piles allowed for deeper foundations with greater resistance against loading. The piles must be founded approximately 30 metres below existing ground level, as can be seen from the borehole information. However, the open pile structure has a less cushioning effect in terms of berthing the ships. And finally, we considered a sheet pile wall. Sheet pile wall, and this again will not have to involve removing the rock revetment. And the major concerns, however, is the Belfast leach conditions under the ground surface. Piles will have to be founded approximately 30 metres. And there's also the possibility of using an anchor system in the form of compression and tension tubes in order to resist lateral forces applied during the berthing movements of the ships. We then put each of these different options into a design matrix and ordered them in different criteria, from functional requirements, constructability, maintainability, the ease of deepening, value and cost, and the duration of construction. The sheet pile wall came out on top, so we opted for this design. In terms of construction sequence, initially the sheet piles would be installed, followed by a backfill in the area between the sheet pile and the existing rock embankment. First stage of piles would be installed, followed by compression and tension tubes and a rock anchor. Second phase of piles would then be installed on top with an anchor block, concrete anchor block, and the ties. Second phase of concrete would be installed, followed by the capping layer and dredging, and then the site would then be brought up to the proposed level.
Okay, now I'm here to talk to you through the overall design of the terminal itself. So I'll quickly start with our design brief for the terminal. So we want to build it for sustainable use up to the year 2030. We're designing it so it has the capacity to be able to berth around 2 cruise liners. So this would be one of the larger cruise liners currently in use at the moment and a smaller one. Due to that, we've designed the building with a 12,000 person capacity. This includes both passenger and crew from the ships. Now, initially this sounds large, but this is what we designed it for a worst case scenario, in case we have both ships in at once. But although that's mostly unlikely, we've also tried to design our terminal so it has large public facilities and restaurants, so that we will encourage people from the local businesses around that will come in and use the terminal. We're also looking for dual use for the building, so that in the off season, when it's not being used as cruise terminals, it may be used for concert or event space. And of course, we're looking for passive and sustainable design. These are here just some of the building requirements we need within the terminal. So obviously we'll need ship services, security and immigration, luggage handling, office and crew facilities, tourist amenities, and like I said, for the surrounding public, shops, restaurants and bars, which will of course be open to everyone. So our concept. So before we started designing it, we were trying to come up with an early concept for the terminal so that we could start moving forward. So we were trying to look at things within Northern Ireland which are interesting to tourists and might draw people in. So we started looking at the Giant's Causeway, and we quite liked the idea of the different levels and thought that was maybe something we could echo within our design. Then we also liked this idea how Northern Ireland and Ireland itself sometimes get nicknamed the Emerald Island, and this idea of trying to create something that was quite green and kind of copied that. And that would again echo sometimes the hills in the background around Belfast. Yeah. So this is some of the other terminals around the world that we kind of started to use as influence. So here we have the Beijing Welcome Centre, and we quite liked how it starts quite low and then it builds up. Although it's more of a smooth curve than the Giant's Causeway, it still has kind of that levels and stuff. So we quite like that. We also quite liked how you could walk onto the roof, and that would give you a view of the surrounding area. Next of which was the Taiwan Cruise Terminal. And again, as you can see, we quite like the levels there for how that echoed the Giant's Causeway. It kind of kept to our concept. And lastly, you'll have to forgive me for my pronunciation, is the Young Island International Cruise Terminal. And we quite liked there how it had a green roof which was accessible to the public. We also had a thought about the materials that we could use within the terminal. So like I said, we were aiming for quite a green roof and a green building altogether. Then we also looked at the use of timber and weathered steel within the facade. We also were looking at copper cladding roofing and obviously large glazing to be used on the southeast side of the building, so that we could possibly design. Here are some of our initial design ideas. So as you can see, we wanted to have this larger space at the bottom with an elongated bit at the end. That way we thought the larger space could be used as the public area and would be good for both concerts and events in the off-season. The thinner bit there at the end, as you can see, would be where we would put the facilities for the cruise. And as you can see here, this is echoed in our final design. Unfortunately, we did move away on the exterior. We did move away from the idea of the Giant's Causeway, but it's not so clear from this design because it's quite early and we aim to move it forward. But we were trying to echo the green roof into the building and on some of the walls there to have moss algae growing up. But then in the interior, this is possibly where we kept more to the Giant's Causeway. We wanted to have level of mezzanines, or rather than floors, level of mezzanines, each acting at different heights. So I'll talk you through how the flow in the building goes. We wanted you to enter somewhere around here, and upon research on a number of terminals around the world, we found that what happens with your baggage is normally your baggage will be taken where you check in, just to be screened privately around the back. So we thought that this is where your baggage will be, or this is where your baggage will be taken. Then you will come into a public area where there will be shops and restaurants on both the ground floor and the first mezzanine. Well, this is the first mezzanine. Then you would come up to the third one where you would start security and start to move on to the actual the cruise itself. What we have here is just a very preliminary structural system, but it's just so you can get an idea of what we want to have in place. So we want to have some sort of steel frame. We also want some sort of truss system to be used within the roof, and that is all, of course, to be pin connected. Lastly, we had a brief look at some of the sustainable technologies we could use within the building. So we were looking at ground heat exchanger, rainwater harvesting, and we were also looking at alternative maritime power, or cold ironing, which is basically the process of providing shoreside electrical power to a ship at berth while its main and auxiliary engines are turned off, this way helping to save fossil fuels. We also briefly looked at rather new technologies that we could use in the building, these being piezoelectric technology and a microalgae green facade. At the moment these technologies are quite new, so we need to have a bit more research before we can commit to them in our building.
Obviously to access the terminal there must be some sort of transport in place. As a sub-team we have devised our essential criteria, which are access to and from the site itself, both for plant construction and for public access once completed. The ability to travel in and around the site once completed, a parking facility for staff and those passengers beginning their cruise in Belfast, and a drop-off pickup area and a coach parking facility. Several options have been devised thus far, and all of which have some common features. Some of these can be seen on the screen in front. The three main entrances are three red circled areas. These are currently non-negotiable at the minute. We plan to have a one-way system, so one entrance point and one exit point, and a separate entrance for service vehicles and rubbish collection. The car park itself, we aim to have approximately 800 parking spaces, 6% of which will be disabled. An underground parking facility to maximise space in the area with one underground level. And also the construction method of the car park. We plan to use a secant pile wall, the construction of which will be to first pile, and then to spray a layer of concrete to give a good finish. Lay a waterproof layer on top of that to give a watertight seal, and then a reinforced concrete slab on top. This concrete slab will be enough to resist the buoyancy of the high water table in the area. This will also be aided by pre-tension pile foundation. Currently, our point of exit that we are proposing is being used as a makeshift car park, as can be seen on the photograph in the bottom corner. This is to service the nearby offices. As we will be removing this facility from the nearby offices, we would propose that they can have use of our car parking in the area. The point of the cruise terminal is to bring in as much tourism and revenue into Belfast and the rest of the country. In order to help this, we aim to provide designated shuttle buses, as the Metro already provide shuttle buses from the current dock in Belfast into the city centre. We would also like to have this facility. A separate bus service for staff to and from the terminal to encourage the use of public transport. A separate coach park for tour buses and shuttle buses itself. And also a new scheme called Belfast Public Bike Share is being launched in March of next year. We plan to link up with this scheme and have one of the 30 docks in Belfast placed in our terminal. We'd also provide bike parking for staff and those who want to use the service.
There are a few environmental issues encountered in our proposal, and we have picked out two major ones. The first one is waste management, and second is dredging. Cruise ship normally generates waste such as grey water, black water, bilge water, and salt waste, and for about 3,000 capacities, approximately 114,000 liters of black water and 960,000 liters of grey water produced per day. So typical cruise ship will normally treat those waste before dumping them to the sea, and our team has suggested that it is best for the cruise ship to dispose those waste 5 kilometers away from the shore. And if they ever want to dispose those waste on our terminal, then charges will be applied. As you can see, this is a map showing the location of the site. According to previous report regarding the dredging works in Victoria Channel, it was found out that the dredge material at our site is not harmful, so it is safe to dispose those dredge materials to the sea. There are two approved, as stated by the Northern Ireland Environment Agency, there are two approved dumping grounds nearby our site, and we have selected number 1 as our dumping ground, as it is much closer compared to number 2. The type of dredger to be used for this proposal is called the trailing suction hopper dredger, and this type of dredger is commonly used in Belfast. It is suitable to carry large load over great distances, and how it works is that the dredger pumps in the sediments as seen in the picture, and it can easily discharge the dredge material to the sea by opening the bottom doors. We have calculated the volume of the amount of material to be dredged, and it is roughly around 594,000 meters cubed, and the tidal range is between 0.4 meters to 3.5 meters, and that the mean sea level is about 2 meters.
Okay, just to tie up, obviously you've seen a lot of our ideas in their infancy, but to complete our project, each group has a series of jobs that they need to complete. Transport will be looking at completing a car parking facility, which is close to completion at the moment. Finalise the access and egress routes, create an internal road system to serve the facility, and this will be used in tandem with the flow rates of the area around the Hollywood site, and will be inclusive of the cycle use that we intend to put in place. Design team, they're looking at finalising the building design and any structural design that will be necessary along with that, along with looking at sustainability and energy issues that may arise. The geotechnics team need to finalise their key wall calculations and their power foundation, along with the ground improvement, which is going to be a massively important job with the poor ground conditions that are already there. And the environmental team need to finalise their environmental impact assessment and design for any wave impacts in the area, as well as finalise dredging calculations and discuss the waste management and any solutions we may put in place to sort that all out. Thank you for listening. We'll be happy to take any of your questions.